In this video, we are going to discuss a great experiment, a very simple looking experiment, but which changed our science. After this experiment, we need to change the theory that what light is, how it behaves. It challenged our thoughts. So let's see what is in this experiment. So here, I'm showing one light wave. Okay, so that's why I'm making like this as a snake, because I want to show that light is a wave. We are assuming, our understanding is that light is a wave. And this light strikes on some metal surface. Let's say this is our metal surface. It was observed when we shine some light, or some light is incident on some metal surfaces, you can eject electron from the metal surface out. So you can get an electron here coming out of the surface. Now think about, if electron is coming out of the surface, what does that mean? It means you can run this electron in the circuit. Oh, then we will get current. And remember this word? Yeah, you can create electricity. You can run your appliances. Now, what is special about this simple looking experiment? You will say, okay, sir, the light shines through some metals and then we get electrons. But what is challenging in that? This word got challenged. That light is a wave. If we are considering light as a wave, the results of this experiment, which we are going to explore, will confuse your mind. Okay, so let's see the results, what they are. First thing is, let's say some wave came here and one electron, I'm showing with this red dot, say it was inside this metal surface and it got the energy from this light wave and it went out. Watch its speed. It is going very slow. It has very less kinetic energy, right? Boring. Now we want to play with it. We want to shine some different light, some with some different property, so that I can change its kinetic energy. I am not liking it. I want it to go just like that, fast. Now, what we can do? What should we do to make the electron go with the higher kinetic energy, or with the higher speed? So here, I'm showing this as a water surface, and let's say this is the shore, Kinara. And I want this ball to shoot up with higher kinetic energy so that I can land it here. So what should I do? It is simple, create waves. So if light is a wave and you want to give it more energy, bring bigger wave, right? Or you want more kinetic energy, then bring even bigger wave with a bigger amplitude. And how we can see that in light? Brightness. We have a word for that. That increase its brightness, this ball will just go up, right? With a higher energy, with a higher speed, and you will be able to land up on this shore. Now let's go back. So I just need to increase the brightness of this light, and that's all. I should get the result. Now the electron which you saw, which was coming very lazy, with a very less energy, will have, or should have, more energy. So when we increase its energy, or when we increase its brightness, and we have a technical word for that, we can say intensity, same thing. Like you see, understand brightness, understand this word also, intensity of light. If we increase its energy, so this electron should get out with higher kinetic energy. But what happened? When we are increasing its brightness, we are having same electron going lazy again. So there is no effect on kinetic energy with the brightness or intensity of light. We are increasing its amplitude, increasing its brightness. It should have more kinetic energy, but it is not happening like that. It is just going up like that and coming back. Oh, that is strange. How we can understand light as a wave? Now we have a doubt. Is light a wave? Now we are getting doubt whether light is a wave or not. Let's write down the first finding, which is that the brightness of the light has nothing to do with the kinetic energy of ejected electron. Or we can say brightness or intensity is not affecting kinetic energy. I'm writing shorthand KE, kinetic energy of ejected electrons. Confused. Why? Bigger wave is coming, more brighter light is coming. Still, we are getting electrons going lazy like that. But does it change anything? Did not get anything out of it. We got, instead of one electron which was going like lazy, now there are more electrons. So the brightness increase resulted in more number of electrons ejected. So these are the results. The brightness does not affect kinetic energy. The electrons will go like that. But instead of, let's say we were having 10, now we can have hundreds of them. But they will be all lazy, all having same energy. They will be just going like, one is going like that, one is going lazily like that, and likewise we can understand. So now how to change its energy? I want this electron to just like fly away like a rocket. How can I do that? For that, let's go and consult our wave theory people. So they told, bring a bigger wave. Nothing happened. Okay. So light has a different property. Let's play with that now. Light has color. And fancy word for that is frequency. If you see red color, that has lower frequency. And if you see blue color, that has more frequency. The frequency increase as we go from, as you know, rho I G B I V. Red, orange, yellow, green, blue, indigo, violet. So as I'm going right side, the frequency of light wave increases. The violet color has more frequency. Red has minimum in our visible spectrum. So this is what we see. These colors humans can see. So how we can create a wave like that which has more frequency? Let's do that. We know the increase in the amplitude or the brightness or intensity is not giving us the results. So what we'll do, we will have a very small wave created here, and it has very high frequency. High frequency means in 1 second, let's say it goes like that. So many cycles of that passes through in 1 second. That is the higher frequency. Let's say it is a blue light because it has higher frequency. See, blue light. I can use violet also, but I chose blue. So this is a high frequency light, right? Now what will happen? Should it affect this? Are you kidding? This is such a small, tiny amplitude wave. It will just jiggle it like this, and that's it. This ball will not go anywhere, according to our theorist of wave theory, right? That is what they will understand. But what happened? As soon as you bring this wave under this shoots like a rocket. It has more kinetic energy according to how frequency higher this wave has. So now the basic wave theory is crumbling. These concepts are not working. How can such a tiny wave can make this big ball jump out of the water surface? Or I can say, how can, if I bring higher frequency light here, how can one electron which is coming out is getting higher energies? So that is our next finding. So our second shocker is kinetic energy of ejected electrons of ejected electrons depends on the frequency of light. So these are the results we are getting, and which are very strange. So the kinetic energy of electron is depending on the frequency of light. Let's say the red light gives me like this much speed. If I increase the frequency, I go rho I G B I V, I go orange, it moves faster. Then I go yellow, it moves faster even. And violet, it just shoots up because frequency is higher, then kinetic energy is also increasing, right? It depends on the frequency of light, not the brightness. Now, one more thing, one more concept here. What if we lower the frequency? Let's say we had a light of green. So I'm just writing it here, Roy G, right? Maybe we are using this frequency light, the green color. So we saw the electrons are coming lazy like that. Okay. What if I go to another color or the lower frequencies? So maybe in yellow color, I'm getting even slower, right? Because it depends on how much frequency of light is there. So my electron is getting ejected, but it is having lower kinetic energy. Let's have orange now. Let's have orange. So orange is just, electron is merely coming out. And what about red? If I use this, maybe in this case, the electron will not even come out. It will just stay here because it has very low kinetic energy. You are not giving it enough speed to come out. And that is what one frequency we call. Below that, you cannot get the electrons ejected out. You will not see photoelectric effect. And that is what called is threshold. Threshold frequency. The frequency below that, if you shine the light, you will not see this effect. And what this effect is called? This effect is called a photo because related to light. We shine the light on some metals and got electrons. So here it comes the second word, electric. and mixing them photo and electron ejection. We can call this effect photoelectric effect. And these are the puzzling results of this. Let me summarize these two results to you. First thing is the brightness has nothing to do with the kinetic energy of electron. It only increases number of electrons, but all electrons will have same speeds, same kinetic energy. If they are at lower speeds, there will be more electrons with the lower speeds. That's all. And kinetic energy depends on the frequency. That's the second result. If we increase the frequency, more the energy. And we also understood this concept of threshold frequency. Let's say the threshold frequency was orange. In orange, you are getting some electron with some speed. But if you go below that, red has a lower frequency, the electron will say, no, I don't have enough energy to come out. You will not see this effect. Now we will go to the next shocker, which completely dismantles the wave theory. Third thing is the electron ejection. The electron ejection is instantaneous. What does that mean? Instantaneous means as soon as you shine the light, the electron is out. There is no time delay. So I'm just writing here, no time delay. But why we are worrying about there should be a time delay? Because if light is shining on this metal surface, there are billions of electrons here, right? Let me zoom in on some electrons. Okay. So there are millions, billions of electrons, right? And now if light is coming with some energy and this electrons wants to go out, it will take some time. Why? Because they will collect energy like this much. They will get tiny, tiny part. Think of giving a pizza to 1,000 people. They will get a very less share. The same way, these electrons will take time to collect this energy. And the calculation which our scientists did, they told that it will take time. It can be minutes, it can be hours, it can be days to see this effect, photoelectric effect. But guess what? Again, the shocker. The electron ejection is instantaneous. There was no time delay. It was not like they are collecting energy. As soon as you shine the light, they were out. There was no time delay. So these results challenged our scientists. They have to come with the new theory to understand this behavior. Because light as a wave cannot behave like that. The results are contradictory. And that is the beginning or of our modern physics, or we can say quantum physics, which we are going to cover in our next videos. Thank you.